Hi all. Did you ever experience joining a new team and finding that every team member uses different work methodologies and nothing is organized across the team? It's inefficient, it's messy, and it makes it very hard to work together. This is exactly where we were 2 years ago when I started Big Panda as a data scientist. I was working in a team that develops ML models for reducing operational costs for our customers. We were a small team when we started, so we set up a quick and dirty solutions for completing tasks. But we quickly realized that the methods we were working with were slowing us down and making it nearly impossible to get things done. My name is Lidiya, and today Nadav and I want to tell you about the journey we went through in the team to identify our methodology problems and to create a solution that would accommodate our work together. But before I get into that, what you need to know about Big Panda is that we are an AI ops product that helps DevOps or NOC teams, for example, to prevent outages and to lower operational costs for our customers. And as our colleague likes to describe it, Big Panda is AI ops, which is like ML ops, just the other way around. Our starting point was a team that grew from 1 to 4 data scientists within 3 months, and each team member introduced their own methodology and tooling. Our development environment was mostly on Databricks. We were developing on notebooks, which meant that we weren't making many Git updates and could not develop with our favorite IDE. In addition, experimentation was done with MLflow, which works out of the box in Databricks, however, was not used too often and did not meet all our cases. Moreover, the path to production was long and slow as we needed to convert the notebooks to scripts on our local IDE. We faced several challenges as each team member had its own work methodologies, its own development environment that he is used to, like development with code or notebooks, locally or remotely. Also, the first setup of Git had big friction as Git methodologies were not so common. For example, each project has its own folder names and files, which made it hard for a new data scientist to get familiar with it. We also had different Git commits frequencies due to different development environments. In addition, for documenting our experiments, some used designated tools and others used Excel files. When we executed the code on our local IDE, it was failing due to memory errors. Then when we wanted to deploy the code, the path to production was long because transitioning the code from remote notebooks to local IDE was messy, as we couldn't locally validate our changes and had to process them on Databricks instead. And finally, we faced production-only bugs, which is bad. And so we realized things needed to change. We set out to identify problems and to determine our baseline and standardize team requirements. What we wanted was a designated IDE for data science projects, containing features like debugging, convenient Git updates, code completion, and visualization. We wanted a fast way to create Git repos for data science projects right from the beginning of the project. We standardized repo content. Also, we needed out-of-the-box ML experimentation. And lastly, and most importantly, we really needed configurable and easy-to-use computing resources, both for research and development, using a remote interpreter that will mimic an environment similar to production. For all of these requirements, we arrived at a unified solution, and Nadav, our ML engineer, will tell you about how we implemented this solution.
So, we knew what we wanted. To get there, we needed to understand which strong qualities we do possess. We have a tech-savvy data science team that can handle a complex environment and advanced tooling. We have an established Kubernetes cluster that already serves development, staging, and production functionalities. And we have developed support within the DevOps team that will help with our effort and provide resources. We were in a pretty good place to start it. So our first move was to deal with the issues of Git usage and project standardization. In order to get everybody on the same page, we sat down and discussed the relevance and frequency of Git commits in the different stages of feature development, starting from the research phase up to production. This process yielded guiding suggestions on how and when to use Git to set a baseline for everybody. We also started using GitHub templates to structure our project on an agreed upon skeleton. Into this skeleton, we embedded some tools we packaged in Python that will abstract away the usage of experimentation, logging, and monitoring, which includes connection to MLflow and quality of life functions. Now we had to deal with the elephant in the room. What do we do about our development environment? Naturally, we wanted to use Kubernetes as our solution, but how? There was the obvious option of running a dedicated server, but that's not why we're all here for. So we could just create our own custom resource that will be tailored to our needs, but that also required a lot of effort we didn't want to put in, not to mention the complexity. Knowing we wanted to use Kubernetes, but unwilling to create a custom solution, we went out and searched for another option. And that is when our DevOps team suggested we use a tool called Octado. When defining it, the author described this open source tool as Octado provides a local development experience for Kubernetes applications. When thinking about it, this was exactly what we wanted. A personalized Kubernetes-based development environment that could be configured to our needs. So we set up specific machines we wanted as resources within our cluster, thus allowing our team the freedom they needed to optimize development. We defined an easy-to-use configuration YAML file that could be modified whenever we needed. If you look at the file, you'll see that the namespace we want to run at, the resources we're about to request, some ports we forward in case we want to use Jupyter, and the types of machines we're about to use. To that file, we also added a disk component to allow install packages to persist between sessions, lowering the setup time of each boot. To recap, on launch, Octado would create a pod within our cluster that reflects a specific development environment and synchronizes changes constantly. So what does this mean for us? Now, all a data science needs to do is to install Octado, copy a configuration file template, and then run a simple command, Octado up, which will automatically connect them to a fresh new environment that they've configured. Simple as that. Well, maybe not that simple. Behind the scenes, Lidiya and I work together to make this process as lean as possible by simplifying the YAML file and choosing the right machines needed for the data science team. Overall, we iterated a few times until we got what we felt was the best outcome. After adjusting to the new system, we started to understand the power and flexibility we had in our hands. Each team member, with their different work methodologies, was able to gain from running on Kubernetes. Imagine you, as a data scientist, have the freedom to choose the type of machines and the resources needed for each step in the task lifecycle, and the flexibility to transition between them with minimal downtime. You could also emulate production by configuring the machines to mimic the desired setup. For example, we recently worked on a new model we wanted to deploy. When running the tests within Lidiya's development environment, everything was great. But when testing on a simulated production environment, we found a bug that we were then able to avoid. All of this means that it is now so much easier to harness the power of cloud computing while still enjoying the advantages of our own personal IDEs, methodologies, and tools. and Lidiya can attest to how much the team embraced the solution and appreciate its benefits.
So if you recall this slide with all the requirements for our work environment, you will be happy to know that we did achieve them all. Today I start my day with Octado app, the command we saw before, using my favorite IDE, which is PyCharm. And that connects me right away with an environment that I've designed, which is similar to production and templated from our skeleton, all thanks to the power of Kubernetes. So next time you find yourself working inefficiently with your team, work together to figure out the pain points. Identify your strengths and list the issues you want to solve. Then invest time to find the proper solutions. Maybe even use the DevOps team for help. Implement it on your work environment, and if you find the tool successful, implement it with the rest of the team. We recommend you work with a standardized Git repository using Git templates, and to also find a convenient experimentation tool that meets all of your needs. If the tool meets only most of your requirements, wrap it with an internal package that will meet all of your requirements, like we did. And most importantly, work with the remote interpreter that will be easiest to use with your local IDE. If your production is deployed with Kubernetes, we strongly recommend you try Octado. But remember, while every struggling team is probably struggling with the same issues, the solutions are not one size fits all and should be customized for the current DNA of your team. Thank you very much.
Thank you very much.